Hi everyone and welcome to Mastercam. So we are going to start the module number 5, which is all about the multi-axis toolpaths, and in this module we are going to learn about introduction to multi-axis and 3+1 and 3+2 rotary positioning. So we can say that 3+1 is 4 axis and 3+2 is 5 axis rotary positioning. And then we're going to study about the swath and swath milling operation and for automatic roughing in 5 axis and multi-axis pocketing and some advanced applications of multi-axis toolpath. So before getting into multi-axis toolpath, let's get to know about how many axes does multi-axis contain. So here we know that we have a 3-axis milling machine, and all 3 axes are defined as X, Y, and Z axis. So these are 3 axes. More than 3 axes we call multi-axis, and for direct axis we defined as A, B, and C axis. So how we can define the A axis and B axis and C axis? So we define according to our previous 3 axes, which is X, Y, and Z axis. So let's start with the x-axis. The rotation about the x-axis is called the a-axis. The rotation about the y-axis is called the b-axis. And the rotation about z-axis is called c-axis. In such case of vertical machining center. If you have a vertical machining center and then you have a horizontal machining center, the case will be same. But as you know that the vertical machining center has the z-axis at a vertical position and the horizontal machining center has z-axis at a horizontal position. But other axes will be same. So let's get introduction to multi-axis toolpath. I'm going to tell you how we can create multi-axis toolpath in Mastercam. So here is an introductory video. So let's get started. So I have already opened the Mastercam and let's make a design. So what I'm going to do is I'm going to create a design on the left plane. So I have selected this construction plane, or so we can say that C plane on the left side. And what I'm going to do is I'm going to draw something which is all about like I'm going to make a polygon. Click on center. So go to view and go to left view. So here we have. So let me make the radius 45 and click OK. So that's it. So we have a radius, so we have a polygon here. We have 6 sides, 1, 2, 3, 4, 5, 6 sides. I'm going to make it solid. Go to solid, go to extrude, and select your method. So I'm going to select the chaining method, and here we have the wireframe. Click OK. So it's prompt where you have to create on this side or on the other side. Then make the on the other side. So just make this direction on the x-axis positive or x-axis negative direction. Okay. So you can create it either on the other side or this side. So it depends upon you. So let's make this distance 150 millimeter. Okay. So we have created a geometry which is a polygon having 6 sides. It's a solid and 150 millimeter in length. And what you have to know that you have an z-axis in the upward direction and x-axis on other sides. Okay. So make sure that the z-axis should be on the topward direction. Now what I'm going to do is I'm going to select machine. I'm going to select default mill machine, and here we have multi-axis tab. So in the previous videos, we discussed all about the 2D machining paths or 2D tool paths. And then we discuss about the roughing toolpaths or 3D machine toolpaths for 3D object. But now we are going to study about the multi-axis toolpath here. So here what I'm going to do is I'm going to give you a simple example how the multi-axis toolpath actually work. And here I just going to select the rotary, which is known as the 4-axis toolpath because it will move around x-axis. You see this is x-axis, and this workpiece will be rotate about the x-axis, which is also known as the a-axis. So for that we have the toolpath rotating. We have to select the appropriate tool. So let me go to selection, and I'm going to select 6mm ball nose. Make the spindle default, feed rate default, and all this default. Just gives you an overview of how a multi-axis toolpath works. Let's define this as a default order. How about the cutting parameters or cutting pattern? So you have to select the appropriate. Just see this picture shown here that how the toolpath will be created. So let me define the surface which we want to finish, a machine. So click here, and I want to machine this surface, or we can say that I have to select all the faces, all the 6 sides. So we have selected, just click end selection, and here we have 2 options. Cut control, cutting method, we have to use the rotary cut or the axial cut. So the rotary cut will be look like this, and the axial cut would be like this. Okay, see, it's all about the according to axis, but this would be according to rotary position. So just make it default rotary position. How about the tool axis? Just make it a simple same, and we have the axis dampening length is 2.5mm from this side, and the lag distance is 0 degree. And how about the maximum step over, or we can say that maximum step is 2mm. The cutter will take 2mm step. So you need to take appropriate value according to your ball nose cutter. Okay. So it depends upon the finishing. So collision setting, linking, all these settings, I just make it default. Just click on apply and OK. So what you see over here is the tool path around my own faces. So let me go to backplot selected operation and just here and play. So this is how the cutter will work around this and make the machine surface or creates machine surface. Okay. So the ball nose is rotating around the workpiece. So let me show you another view, the actual view how it would work. So go to options, and here we have some options here. So simulate rotary axis. So I just selected the simulate rotary axis option, click OK, and this is how you see the cutter will work. Okay. So this is how the cutter will work like. So it looks like it's working on a rotary position. Okay. So we have another option here. Go to parameters, go to cut parameters, and we have the rotary cut positions and axial cut. So let me select the axial cut, and now go to axis control. So the rotary cut options are disabled now, and the axial cut options are enabled. So we have the maximum angle increment. You have to define the angle of increment. Let me define at 6 degree, and starting angle is 0 degree, swipe angle is 360 degree, and total vector length is 25mm. Okay, so just define OK, and what you see over here is the cutter will be work on the face parallel. Okay. So go to backplot setting and click play. So what you see over here, the cutter will work like this. So this is how the 4-axis cutting toolpath work, or we can say that multi-axis rotary positioning work. So this is a how-now video how multi-axis works. In the upcoming video, I'm going to tell you in detail how we can set the rotary position for 4-axis and 5-axis machining and multi-axis for roughing operation, pocketing operation, and swap milling operation and curve milling operation. So hopefully you understand this video. Let me show you some more options here. Go to parameters, and here we have some vector tool lengths and some distance over here. Okay, so you can make it 1 degree increment, so it will be more close to the path. It gives you more finish, we can say that. So go to backplot, click here, and this is how it will work. So it's just rotating. Okay. So hopefully you understand how I have selected an appropriate tool, and then what I did is I just make a tool path around the profile, around this polygon profile, and make it rotate. Okay. So this is all about the multi-axis toolpath. So thank you very much.